I'm going to be talking about linear equations. A linear equation is an equation where no operation is performed on any variable besides addition, subtraction, or multiplication and division by a constant. So y equals 7x minus 2 is a linear equation. A plus b over 3 is equal to minus 12 is also a linear equation. But x squared is equal to 1 minus the square root of y is not a linear equation. That's because x squared is multiplying one variable by another, which is not allowed, and square root of y is performing a square root on the variable y, which is also not allowed. Now, a linear function is a function which is defined by a linear equation. If we define a function f as f of x equals 2x plus 5, this is a linear function since the relation defining it is linear. This notation here means that f is the function with the set of ordered pairs x comma y so that y is equal to 2x plus 5. In fact, it turns out that any linear function can be written as f of x is equal to mx plus b, where m and b are some real constants. Let's graph some linear functions so that we can learn more about them. Suppose we have the equation y is equal to minus 2x plus 1. Or we can write this as a function, f of x is equal to minus 2x plus 1. Now suppose we want to graph this. This is the x and that's the y-axis. This will look something like this. There are three important properties that linear functions have, which we'll now discuss. The first two are the x and y intercepts. Firstly, the y-intercept is the the y value of the point where the y-axis intersects the line. Since all points on the y-axis have an x-coordinate of 0, we can solve for the y-intercept by plugging in 0 for x and finding out what y is. So y is equal to minus 2 times 0 plus 1, which is equal to 0 plus 1, which is just 1. Notice I've indicated on the graph this point 0, 1, where the y-axis intersects the line. Similarly, the x-intercept is the x-coordinate of the point where the x-axis intersects our line, which would be right here. To solve for this using our equation, we simply plug in 0 for y, since all points on the x-axis have a y-coordinate of 0, and solve for x. We have 0 is equal to minus 2x plus 1, so 2x is equal to 1 if we add 2x to both sides. Finally, dividing both sides by 2, we get x is equal to 1/2. Finally, let's talk about the slope of a line. The slope of a line is how much the y-coordinate changes in proportion to how much the x-coordinate changes when we move along this graph. So if we move from this point here to this point here, the difference in the y-coordinate is here, delta y, along this line, and down here we have delta x, or the difference in the x-coordinate. So in this case, the slope is going to be equal to delta y over delta x. Notice that since this graph is actually a straight line, we can choose any 2 points and take this ratio and it should be the same everywhere. In fact, this is true for all linear functions, which is why they're called linear functions. They define lines. Now if we actually want to evaluate the slope, let's just look at our equation. We know that y is equal to minus 2x plus 1. So if we increase x by, say, 1, then since it's multiplied by minus 2, y should decrease by 2. So if delta x is 1, delta y should be minus 2. So we can write delta y over delta x equals minus 2 over 1, which is equal to minus 2. Notice that this is always going to be equal to the coefficient of x in the equation of our function, but only if the function is written in this form, as y equals mx plus b for some values of m and b. One last thing I'll talk about is parallel and perpendicular lines. If we have a function, a linear function, f of x is equal to mx plus b, then any function with the same slope, say g of x is equal to mx plus b plus 3, is going to have the same, or is going to be parallel to the original line. So this is parallel. And any function, say h of x is equal to minus 1 over mx plus b, is going to be perpendicular to f of x. For the line to be perpendicular, its slope must be minus 1 over the slope of the original one.